Today we're going to talk about section 3.6 on complex zeros. So the first topic we're going to talk about is the imaginary unit I. Sometimes we want to solve the problem x squared equals -1. To do this, we need to define some kind of solution to this equation because no real number actually satisfies this equation. In order to do this, we define this imaginary unit I. So we're going to define a system of imaginary numbers. The most basic complex number is I, defined to be I is equal to the square root of -1. This is commonly called an imaginary number. I itself is sometimes called the imaginary unit. Any real multiple of I is also an imaginary number. So if we look at an example that says simplify the square root of -9, then, well, I know that -9 is the same thing as 9 times -1. This allows me to break this up into two separate square roots, the square root of 9 times the square root of -1. I know that the square root of 9 is 3, and I know that the square root of -1 from this definition is I. So this means that the square root of -9 is 3i. A complex number is just the sum of an imaginary number and a real number. So a complex number is a number z equals a plus bi, where a and b are real numbers. A is called the real part of the complex number, and b, or bi, is called the imaginary part of this complex number. And remember, I is equal to -1. So we have some arithmetic that we can perform on complex numbers, of course. Adding these kind of occurs in the way that we would expect it to. We add the real parts and we add the imaginary parts. So if I'm adding 3 minus 4i and 2 plus 5i, I'll write it like this. 3 minus 4i plus 2 plus 5i. I combine the real parts. 3 plus 2 is 5. -4i plus 5i is plus 1i. For this next one, let's see, 3 plus 5 is 8. 2 plus -3 is -1i. So once again, we just combine the real parts, we combine the imaginary parts. And this last one, -2 plus 1 is -1. -4i plus 6i is plus 2i. And that's it for addition. For subtraction, if I subtract 2 plus 5i from 3 minus 4i, so this is saying I have 3 minus 4i minus 2 plus 5i. Same thing, addition and subtraction are really like the same thing, right? 3 minus 2 is 1. -4i minus 5i is -9i. 2 minus 3 is -1. -3i minus 2i is minus 5i. -5 minus 6 is -11. 3i minus -i is the same thing as 3i plus I, so this is plus 4i. Multiplying by a real number, I just distribute the real number to all of these terms. So if I multiply 4 times 2 plus 5i, this is just 8 plus 20i. Oh, sorry, I have a little bit of lag here. There we go. 8 plus 20i. For this next one, 6 minus 2i times 5. So it doesn't matter the order of the multiplication because multiplication is commutative. So 6 times 5 is 30. Minus 2i times 5 is minus 10i. 8 times negative 2 is negative 16. 8 times 4i is plus 32i. Now if I multiply by an imaginary number, let's see, 3i times 5 minus 2i. So this is going to be 15i minus 6i squared. Remember that previously we said that the square root of negative 1 is I, which means that I squared is negative 1. So if I see an I squared, I can replace an I squared with negative 1. So this is going to become 15i plus 6, because negative 6 times negative 1 is plus 6. Or if I wanted to write this like I typically write complex numbers, then I'd write that real part first. For this next one, I get 8i plus 12i squared. Same idea here. I squared is negative 1, so I replace I squared with negative 1. This is 8i minus 12, or negative 12 plus 8i. Typically, we prefer to write complex numbers with the real part first. So let's look at what happens if I multiply two complex numbers. 2 plus 3i times 4 minus I. So this is 2 times, using the distributive property here, 4 minus I plus 3i times 4 minus I. This is 8 minus 2i plus 12i minus 3i squared. This is 8, negative 2i plus 12i is plus 10i. Then this is minus 3 times I squared is negative 1, like we just discussed. This is 8 plus 10i plus 3, which is 8, or rather 8 plus 3 is 11. This is 11 plus 10i. Okay. For this next one, here, let me swap to, I'll swap to red. 4 minus 2i times 4 plus 2i. So this is 4 times 4 plus 2i minus 2i times 4 plus 2i. And notice how these are like the same thing, but the sign in the middle is different, right? The sign between these two things is different. That's the only difference between these two terms. Notice that this one is going to multiply out to be kind of special, so we'll see what that result is. This is 16 plus 8i minus 8i minus 4i squared. Notice I have plus 8i minus 8i. This imaginary stuff in the middle cancels. So this is 16 minus 4 times negative 1, because I squared is negative 1. This is 16 plus 4, which is 20. And this is going to be related to a concept that we're going to discuss in just a second. But before that, let's do one more example. Here I have negative 1 times negative 2 plus 3i plus 2i times negative 2 plus 3i. This is 2 minus 3i minus 4i plus 6i squared. This is 2 minus 7i plus 6 times negative 1. And this is, let's see, 2 minus 7i minus 6. 2 minus 6 is negative 4. So this is negative 4 minus 7i. And let's look at division, of course. If I want to divide a complex number by a complex number here, I have to eliminate the complex number that's in the denominator here in the example that I have. In order to do this, typo. In order to do this, I have to multiply the top and bottom of this fraction by a special complex number that we're going to call the complex conjugate of the denominator. This is the same thing as the denominator, but with the sign changed. So we're looking for something similar to how we had in this problem, where we had 4 minus 2i times 4 plus 2i. So we have this definition of a complex conjugate. The conjugate of a complex number, a plus bi, is the number a minus bi. The notation used for conjugation is a bar. So the complex conjugate in this problem that we're looking at, we want to look at the complex conjugate of the denominator. So the denominator is 4 minus I. So the complex conjugate of 4 minus I is 4 plus I. So I want to multiply the top and bottom of this fraction by 4 plus I. Let me copy and paste this problem. So I'm going to write the problem again. I have 2 plus 5i over 4 minus I. And I want to multiply the numerator and denominator by this complex conjugate, 4 plus I. Notice that I'm really multiplying this problem by 1, so I'm not necessarily changing anything. Now I need to distribute everything. Up top, this becomes 2 times 4 plus I, plus 5i times 4 plus I. On the bottom, this is going to be 4 times 4 plus I, minus I times 4 plus I. And now I simplify. This is going to be 8 plus 2i plus 20i plus 5i squared divided by 16 plus 4i minus 4i minus I squared. Remember, I squared is negative 1. So this is 8 plus 22i plus 5 times negative 1 over 4i minus 4i cancels in the denominator. So I have 16 minus negative 1, because I squared is negative 1. So I have 8 minus 5 up top. 8 minus 5 is 3 plus 22i over 16 minus negative 1 is 16 plus 1, which is 17. Or we might write this as 3/17 plus 22i over 17. And this will be my answer. Let's look at some more examples. I have 2 more. Okay. So here, I want to multiply by the complex conjugate of this denominator, which is going to be 4 minus 3i. So multiply top and bottom by 4 minus 3i. This gets me 2 times 4 minus 3i minus 3i times 4 minus 3i all over 4 times 4 minus 3i plus 3i times 4 minus 3i This is 8 minus 6i minus 12i plus 9i squared all over 16 minus 12i plus 12i minus 9i squared. Let's see, this is 8 minus 18i plus 9 times negative 1 over 16, the i's cancel in the middle, right? Minus 9 times negative 1. This is 8 plus 9 times negative 1 is 8 minus 9. That's negative 1 minus 18i over 16 minus negative 9 is 16 plus 9, which is 25. And we might write this as negative 1/25 minus 18i over 25. Just break these up into two separate fractions. And the next one, I multiply top and bottom by 2 plus I, because that's the complex conjugate of this denominator. This gives me 3 times 2 plus I plus 4i times 2 plus I all over 2 times 2 plus I minus I times 2 plus I. This is 6 plus 3i plus 8i plus 4i squared all over 4 plus 2i minus 2i minus I squared. This is 6 plus 11i plus 4 times negative 1 all over 4 minus negative 1. The 2i minus 2i cancels. This is 6 minus 4 is 2 plus 11i over 4 minus negative 1 is 5. And we could write this as 2/5 plus 11i over 5. Let's see here. I'm going to break this into a separate video. Okay, I'm going to stop the recording here and turn this into a separate video.